look at is that we can try to find the limit for this particular function. Let's say it's the limit as x and y approach 0, 0 for the function of x, y to the fourth, divided by x to the fourth plus y to the fourth. Okay, so if we want to identify this particular limit here, then one of the first things that we can do is we can start picking paths to try to see if the limit will in fact exist. And you can pick paths along y is equal to x, you can pick paths along the x-axis, y-axis, along x squared, around the square root of x, an infinite number of paths. And you're going to find that all of these paths will lead you to a limit of this function being 0, as x and y are approaching 0. Now, one of the items that we can see then is we can start off by making a comparison. And if you want to take this approach, I would always venture to say that you want to build this comparison, and you always want to compare some portion of the denominator to some portion of that numerator. And in this case, y to the fourth will be less than or equal to x to the fourth plus y to the fourth. Alright? Now, in order for me to proceed from here, what I'm going to do next is I'm going to divide both sides by x to the fourth plus y to the fourth. Now, doing so will then give me this particular inequality, less than or equal to 1, alright, which is essentially where I want to work at, or not work at, but essentially where we want to be. Now, because we're at this particular place, we want to identify then when is this going to work, and is it going to work all the time for us as these x and values are going towards 0, 0. Now, one of the items that you want to work with to guarantee that this will always work and it will always be less than or equal to 1 or greater than or equal to 0 is by applying this absolute value as we start multiplying by x. Now notice, if we multiply just by the absolute value of x, because the absolute value of x will always be positive, it won't change the order of this inequality. However, we get something real nice when we do so. Now, would you agree that x to the fourth plus y to the fourth being divided by y to the fourth, or vice versa, will always be positive, therefore it can be inside of the absolute value. Now, when we do this, we can then apply the limit to all parties here, as I'm doing here, taking the limit as x and y is approaching 0, 0, for x, y to the fourth divided by x to the fourth plus y to the fourth. Alright, now you can follow me on this to say that if we take the limit of the absolute value, it would be the same as taking the limit of the inner function first and then taking the absolute value of that limit. And we can refer back to Calc 1 when we went ahead and when we proved that result. Now, taking the limit here, we're then going to be able to see that this limit will in fact converge to 0 because it's being squeezed by two functions. Now, because it's being squeezed by those two functions, one below, one above, then we naturally get that the limit for x and y, that it's approaching 0, 0, will in fact just be 0. Now, this is using the squeeze theorem.